We bring proud greetings from Kumasi Academy to you all. We are representing Kumasi Academy for this year's Stemnnovation competition. And on the themes given, that was flexible use of electricity, water purification, and urban garden. We are focusing on urban garden. From our investigation, we came up with a number of problems facing our urban centers, and that includes food insecurity. This food insecurity is as a result of climate change, less space for farming activities, and rural urban migration, all of which have collectively strained the capacity of cultivating fresh produce in our urban sectors. In response to these challenges, we have come up with an innovative approach which tackles these problems effectively, and we call it the smart urban garden. Our smart urban gardening adapts the concept of vertical farming. So, with a vertical farm, it can be housed in abandoned mine shafts, shipping containers, tunnels, and so on. With this structure you see here is the structure we chose to house our vertical farm.
So these are the methods we went through to find information on our project. First of all, we conducted a survey. We conducted interviews. We gave questions to our members, especially the students, to know what they know about the vertical farming. We did a literature review. This means we did a research on it to find out how advantageous it is to society. We did a design and a prototyping. Since we'll be also using lots of technologies, we sat down with our team of programmers to develop a code, test it, and debug it. Thank you.
In order for us to know how feasible our system is, we sat down as a team and we designed our prototype using things like that. So with our design, we have our vertical farm here, and this is our filtration system. We have our storage tank here, and this is the apartment in which we'll be channeling liquid kitchen waste into the filtration system, which will be filtered and be transferred back into the storage tank. And we have a fish pond here. So with this fish pond, we'll be collecting the liquid waste which will be transferred into the storage tank for irrigation. So with our design, we have our control panel here as you can see. So with this our design, we are able to come about that even with a small piece of land, it is possible for us to construct this our vertical garden.
In our system, water for irrigation will be collected from the communities. In the communities, the water can be obtained from two places: the wastewater from the rooftop waste pond and the liquid kitchen waste. Those waters will be channeled into our water channel. From the water channel, the liquid kitchen waste will be moved to the filtration system, and then the water from the fish pond will go into our irrigation system. We aren't going to filter the water from the fish pond because the water in the fish pond contains some essential nutrients that will be needed for the plants for growth. The water in the filtration system is filtered and then moved to the irrigation tank, where the water will then be used to irrigate the system. Since in this project we want to conserve as much resources as possible, we will also be collecting rainwater. That rainwater will then be collected into the irrigation tank and then used for the irrigation of the plants.
So this is a smart urban garden. It's a smart urban garden in the sense that it reflects the wide range of technologies to make urban agriculture more effective, productive, and sustainable. These technologies is going to help the urban gardener to precisely monitor and control the environmental conditions, optimize plant growth, overall yield, and resource usage. So we propose a vertical structure for this innovation. We are using vertical structure because it's going to save a lot of space. It's the process of planting in vertically stacked layers. So with this project or this innovation, it can be practiced by estate developers, individuals, and also institutions. To delve into the smart technologies used in this innovation, we are going to talk about the grow light. The grow light should be used to provide light for the crops in a situation where there is low or no light at all. These grow lights are going to be used to provide light for the crops, and we are going to use an LDR to detect when there is low light intensity. It's working on the principle of photoelectric emission. So whilst there is low light intensity from the sun, we are going to use a grow light to provide light for the crops. With our grow light, we decided to blend two LEDs, which is the red and the blue LEDs. We did it because this is the most needed light in the face of photosynthesis and also germination and early seeding. We are also blending these two colors to prevent a situation known as photomorphogenesis and photoinhibition. We also have humidity sensors. These humidity sensors are going to be used to check the humidity of the whole system. This value is very important to the farmer because if the humidity is too high, there can be a production of bacteria and mold. So this humidity sensor is going to be used to print the humidity value so that the farmer can take necessary actions. We also have the moisture sensors. The moisture sensors are embedded inside the soil. They have two electrodes, one embedded inside the soil. The soil acts as a dielectric material. There's an AC circuit on this sensor, which is going to send AC signals into the electrode, and the frequency of the signals can be calibrated to know the moisture content of the soil. So if the moisture content is below our threshold, there's going to be automatic irrigation. So to experiment, I'm going to take the moisture sensor out. So as you can see, once the moisture sensor is out, there's automatic irrigation, and once I place it back in, there is irrigation stop because the moisture is accurate for the plant to grow. We also have temperature sensors. These temperature sensors will be used to check the temperature of the system. This temperature is very important because if the temperature is too high, the rate of the evaporation and transpiration will be high, and the crops and the land is going to lose a lot of water. We are also going to talk about the energy source of this system. We choose to use clean energy, so we are going to make use of solar panels. The solar panels are going to charge batteries, and we are going to use to power this whole innovation. So these are the rechargeable batteries that the solar panels is going to charge, and we are going to use this power to operate our system. We are also considering the factor of security because this innovation is situated in the urban areas. The security problems will be very high, so we are going to make use of motion sensors. These motion sensors use infrared light to take the temperature of the object or intruder. Once it is detected, a buzzer will beep and a green light will come on to detect that there's an intruder and the necessary actions will be taken. We are also having we are also having smoke sensors. The smoke sensors are going to be used to check whether there is a fire outbreak. So on top of all things, this is a big structure and a tall one. So we are going to use elevators to transport people up and down the system. So this is the elevator. And once we use our control panel, we can control the elevator to go to any floor so that we can help transport people and goods from the whole system.
The main source of water for irrigation is obtained from the houses in the community. So with this house, we channel liquid kitchen waste, which is being transported into the filtration system here. So this filtration system has the ability to filter all the harmful substances, after which it is being transported into this tank for irrigation. We also transport liquid waste from the fish pond into our tank here for irrigation. In this system, there's several technologies. We have rain sensor here. This rain sensor has the ability to detect rain, and when rain is detected, it closes automatically in order to prevent overflow of the fish pond. So it closes automatically when it detects rain, and when it dries off, it opens automatically. So here is an elevator. In order to access the fish pond easily, we provided elevator here which can transport human up in order to access the fish pond. So you can see the elevator moving. And this here is water level indicator. This has the ability to measure the quantity of water in the tank and display it using the LED.
Our smart urban garden helps community inclusive. That is, people in the community are encouraged to practice it at home by growing shallow rooted crops like beans and spring onions at their balconies, which is going to increase connection to nature in our urban cities, which our project aims to address. There is no doubt that the smart urban garden here comes along with a lot of economic and social benefits, being its provision of jobs for both the skilled and unskilled labor. The skilled labor is going to tackle the aspects of robotics and automation, and the unskilled labor it will be the farm hand. There will be a year-round supply of food if this project is situated in our urban communities. It is also going to reduce the transportation cost for food. This project can also set aside educational material, so workshop can be held for schools and communities to create for schools and communities to create awareness about sustainable food production. So with every leaf that unfolds, every fruit that ripens, and every sensor that receives data, our smart urban garden here represents our shared commitment to urban gardening. In conclusion, the smart urban garden here speaks about innovation and sustainability.
Throughout this project, we've explored the balance between plants, fish, and the environment as a whole, and we've seen the remarkable benefits it comes along with. Thank you.
Pouvoir, to wishes to be able, vouloir c'est pouvoir, the motto of Kumasi Academy, oh Lord.